Okay, so we're back and we're rolling, rolling. Keep on going, rolling, right? Okay. So what are we doing? We are talking about the abacus and we are going to be counting 1, 2, 3, 4. After 4, we have 5. 5. How do I know? Because all the lower beads has a value of, no, all the lower beads, wait, all the beads, all the top beads has a value of 5. So what we're doing is we're counting on the abacus, the horizontal bar, this thing, this line over here is my horizontal bar. This horizontal bar tracks my beads, tracks my numbers, tracks my beads. So if I do this, the blue bead always has a value of 5. Always has a value of 5. The lower beads always have a value of 1. So this is 4. 1, 2, 3, 4. Notice these ones all are zeroed. So none of these are being tracked. The only ones that's tracking is this one, because it's touching the horizontal bar. Does that make sense? Yeah, let me know if you're a horizontal bar. Write in horizontal bar if you're tracking. So this is 4, and then we have 5. After 5, we have 6, 7, 8, 9. After 9, we have 10. So how does this work? This works just like as we write just as we write. So when we write, we have our ones, tens, hundreds, thousands, 10,000. Same thing on the abacus. We have ones, tens, hundred, thousands, 10,000. When I'm writing, this would be 10. Just like we have here, 10, 1 and a 0. If we want to do 710, we do 700. See how it's 700? So it's 710, 1 and 0. So our ones, tens, hundreds, thousands, and 10,000s. Just as I have here, I am writing it. Oh, I don't know if you can see that. I'm writing it just like my abacus. So my abacus, I have 7, 1, 0. Ooh, so maybe I should erase that. Let me erase that. I can count to, ooh, but nothing on my fingers. But hey, that's fantastic, Ghostman. So you said 1,023. So it's 1,023. So if I did it on my abacus, I do 1,023. That's how I do it on my abacus, but I don't count it on my hands. And then if you notice, the 1,000 is the comma. This comma is also has an indicator. That's where this comes into play. So if you notice, I have a dot indicator. The dot indicator, thank you, Ghostman, for letting me know. The dot indicator helps label the ones place. So I chose this one to be my ones place. So when Ghostman said 1,023, 1,023, I use this as my ones. So I have ones, tens, hundreds, and thousands. Thank you so much. It's just binary, but with your fingers. I don't know binary. That's a little bit like above my pay range. So if we're going to continue, if I had 1,023, I can make this 1,028. How did I do that? Well, I added the 5. The top bead will always have 5 no matter what. Hey, Ethan, good morning. All right. So what's going to happen is we have 1, 2, 3, 4, and then 5. The top bead will always be 5 no matter what. So as we count, we have 5, 6, 7, 8, 9, and then 10. 10, 20. So we're going to count by tens now. 10, 20, 30, 40, 50, 60, 70, 80, 90. So after 90, how do I know? This is 9 and a 0. So if I wrote it, it would be 9 and a 0. That's what 90 would look like. Just as we write it, it would look like that on the abacus. So then we have, let's say we did this. Let's do 100s, right? So 190, 290, 390, 490, and then 590. Again, anytime the top bead touches the horizontal bar, that's counted. That's counted. This is my horizontal bar, this bar right here. And if you notice, I have some indicators. These indicators will indicate that and help me label that this is the ones place. You could choose this one or you could choose this one, just like in Pokemon, right? In Pokemon, you can choose your Pokemon to help you battle. This one is, I'm going to choose my dot to tell me which one is home. So I can have my home here or have my home here. So this is 590, and then 690, 790, 890, 990. Thank you so much for the hearts. Thank you so much for the hearts. So that's what that looks like. 990. 990. That's what that means. Let me know if anybody has any questions on the abacus. So this is the abacus, and what we're doing is we're counting. The first thing we got to do is understand how to read the abacus. When we read the abacus, it'll be easy to do adding, subtraction, multiplication, and division. It's hard to explain. Yeah, binary is a little bit. Glenn from Jersey, Joyzy. Hi, Glenn from Joyzy. Oh, so your number is 564. So we have 564. That's what that means. Anyways, have a good night. Have a good night to you too, Ghostman 2. I hope to see you soon. Hey, Ethan, 8 times 6 plus 5. Nighttime math. I ordered my... Oh, JB, welcome. Yeah, right. Let's go. I ordered my abacus. It's on the way. We could do that, but 53. So what would it be? It'd be 6 times 8 is 50, 42, and then plus 5 is 47. I always thought an abacus would be for keeping score, not calculations. You know, TNG, it kind of is just to keep track of the score. Is it 13? It's not 13. I'm sorry. 8 times 4 is 48. Sorry. 48. 48. And then plus 5 is plus the 10 minus the 5. 53. 53. Yeah, TNG. So we're going to be counting on the abacus. The first thing we need to do is understand how to read it. So the first thing we're going to do is read it. 1, 2, 3, 4, because it's touching the horizontal bar. As it touches the horizontal bar. Oh, I was telling him that I ordered the 13 column. Yeah. Nice. This is the 13 column abacus. I see now. I see. So notice with the 13 abacus, we can still do the counting. TNG was the best. TNG was the best. What's TNG? I don't know what TNG is. Does it have a reset button? So we're going to count TNG. 1, 2, 3, 4. Let's go, math. Yeah, hey, Frank. So we have 4. Because it's touching the horizontal bar, I just followed TikTok, made you disappear for a few. I'm glad I found you again. Whoa, hey, Thang! Welcome back. I've seen you. Yes, I'm sorry. Okay, so we have 4 and then we have 5. So all the top beat has a value of 5. Now, this works exactly the same as this. The only difference is the different colors and the size. Actually, size matters, just so you know. What does that mean? Well, now, because I have 13 columns, I have a bigger chance. I have bigger numbers. My numbers can be larger. So I can do ones, tens, hundred thousands, 10,000, 100,000, 1 million. Whereas this one only goes up to 10,000. However, if I choose to do here, if I choose this to be my home, if I chose this dot indicator like Pokemon, I choose you. This dot indicator, then I have trillion. I have ones, thousands, millions, billions, and trillions. And so if you want to track the national debt, you might need a 23 column abacus. And that will go to, I don't know how big that is, but 23 columns. So then we have and it starts the same. Ones, thousands, millions, billions, trillions, quadrillions, quintillions, I think it is. So, but this one is kind of cool because on my 23 column one, it's got a reset button. I kind of like it, but this is kind of old. This is an old one. I think they still make it, but I think the beads are plastic. This one here is made out of bamboo. I'm sad. Oh, there's no Abacus Pokemon. Oh, sad face. But there's a Pokemon Abacus trainer. Oh, hey, fun character. I will have to take a look. You know, I was looking, somebody mentioned that Tinkerbell the movie, one of the fairies was using an abacus. So I took a picture of that and I'm like, that's going to be part of my abacuses everywhere. Abacus is, everywhere. We just don't know it. So there was one where Kung Fu Panda was talking to a lizard or a gecko, and they were like talking about all this math and blah, 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 blah. And then Kung Fu Panda's like, is that like abacus or something that came out of your mouth? And I'm like, oh, I need to grab that little snippet as well. But yeah, abacus is everywhere. We just don't know it. Oh, TNG. Okay, TNG. We're back to TNG. Do you understand how we're counting? So we go 1, 2, 3, 4, and then 5. After 5, we have 6, 7, 8, 9, and then after 9, we have 10. Just as, yeah, no, I don't know. It never mentioned. Kung Fu Panda was talking about, I don't know. I'm assuming that they were talking about the Chinese abacus, but I don't know. 6, 7 on that one. I think I got it. All right. I'm actually kind of old and I don't use those words. I don't have the common, I don't have the, what the kids lingo. Okay. So this is 10. How do I know this is 10? This is 10, 11, 12. Because just as we talk about our place values, we have our ones, we have our tens, our hundreds, our thousands, and our 10,000. Only count the beads touching the bar. That is correct, Kim. Thank you so much. Yes, absolutely. NY, thank you so much for sharing my live. Okay, so we have liftoff. No, we have 0. We have 1, no, 10, 20, 30, 40. So anytime, so notice with these columns, these are all 0. I just learned more from you in 1 minute than I did. Whoop, whoop. Thank you, NY. Thank you. I appreciate that. But we're just counting right now. We're going to actually do some adding, subtraction, multiplication, division. Depending on how tired I get, we might get into division. But the interesting thing about the abacus, it's very concrete. I mean, you guys can see it through the camera, but I can touch it. That sounded really creepy. All right. 1, 2, 3, 4, and then 5. 6? No, that's not 6. 6 is here. 6 because you got to keep it together. Keep it all together, and that is 6. So after we have 6, we have 7. 5 plus 2 is 7. 5 plus 3 is 8. 5 plus 4, right? 5 plus 4 is 9. So when we keep it together, this is 9. This is 9. So each column, each digit has a 9, always have a value of 9. And if you need to go higher than 9, it would be the next column. So if I need to do 100, because this is 99, the next column would be 0, 0. Isn't that what competition math is using in Abacus in your head? Oh my God! You're absolutely right, TNG. You're absolutely right. So there's actually other like actual Abacus competitions, which is really kind of cool. Hey, Julian, welcome back. Looking forward to triple digit multiplication. Oh, how long does it take for people to usually get this in their heads? Mathletes. Oh, interesting. Or Olympiads is the other one. But I'm not sure. Okay, sorry, Julian. How long does it take? You know, if they're small, like if they're little, like maybe 5 or 6, it might take them a few years. How's your book going? You know, it's going pretty good with my little abacus one. It's not too bad. I mean, I have this one, and then I have a book 2. If you're interested, I have a book 2. And then Kaylee, hello Kaylee, welcome back Kaylee. And then I have the other book. But I'm still making headway. I told myself that I cannot go live until I do at least a few pages. So I got a few pages, and it's coming along. I think we're talking about the adult one, right? We're talking about the adult one. It's coming along. I haven't yeah. It's going slowly. But I enjoy all the lives. All right. So when we count, let's see. Let's try something new. Let's do some figuring out. What is this number? Put it in the chat what you think this is. How about? Can we teach times table with the abacus? No, actually, we have to memorize our times table, but we can do multiplication and division on the abacus. We can teach the times table, but it would be cumulative addition. So it'd be, thank you, Kaylee. No, actually, it'd be 56,354. Yes, thank you, Zach and Julian. 6,354. Yeah, yeah. It's funny. I was listening to something that said attention to detail. I'm like, I need to use that word, attention to detail, because as long as we look at the abacus, that's why like I actually hover over my abacus to see what numbers are being counted. So tarot. So what I do is I would say like they would have to know their multiplication, they would have to know their additions, and they would have to know their formulas. So what I do is I tell them, okay, count by twos. So 2, 4, 6, 8, and then 10. Right? So then they would know this, and that would be the addition. That would be the addition. Cumulative addition. I think that's what it would be. Can you have it up where the word abacus? Can you have it up where the word abacus is when it's time for us to give an answer? How did you get into using the abacus? Thing, I don't know what you mean. Can you have it up where the word abacus is when it's time for us to give an answer? I don't know how I'd have to do that. I have to figure that out. How did I get an abacus, Julian? I got an abacus because my dad had a business trip and a lady said, "You got to teach abacus in America." And my dad's like, "I'm going to teach abacus in America." And because he wanted to open up a side business, right? So we have a learning center, but he didn't learn abacus. He actually forced my brother and I, and we were like, "I don't like abacus. What's the point of it?" And actually, when I started going down the path of learning abacus, it was crazy. Can I move it up? Where the abacus is on the, oh, I see. I can't see when I go type it. It's like is that better? So my brother and I, we actually have a learning center out in Monterey Park. So if anybody's in Monterey Park in California, we have a learning center, and we teach abacus. I've been teaching abacus for about 20 years now, and I really do appreciate the abacus method. I have 3 boys, and they've all, it's off the screen now. Oh no! Wait. Oh wait, what's off the screen? This? No, this? I don't know what we're talking about. It's off the screen. Oh, the abacus, like this. I see. Like that. Okay. Oh, I need to zero it out. So my brother and I, oh, you want the answer? Oh, what is the answer? Let me see the answer. 6,354. There we go. Yeah. So what happened was we started learning how to use the abacus, and then I was like, okay, you know what? I wanted to see if he wants you to slide it up to frame the key so he could see the keyboard up. Like this? But then my face is in the way. Like that? So yeah, and so I learned the abacus. I have 3 boys, and they all learned the abacus. There's a whole abacus curriculum, and I'm so confused. Can you place it? Can I place this above the bear like that? Okay. You guys are so funny. Okay. So, Thang, you're so funny. So I've been teaching abacus for about 20 years, 20 plus years. And so what really spawned me doing this online is because my dad decided to retire, and I didn't want to have a learning center. I wanted to see what I could do online. Dang, don't mention it. So I wanted to try to get abacus online and get it more mainstream and get it more popularized. So a lot of what I talk about is using mainstream math to explain what we're doing in Abacus. We don't, in the Abacus world, we don't do what I'm doing right now. It's me. Hey, Miro. My name used to be too. Oh, okay. I remember your favorite engineer. Yeah. Oh, you changed your name. Thank you so much for letting me know. So I noticed, like, in the Abacus world, and even in the school, we were telling the kid, we were only accepting kids that were 5. They had to know their numbers, and the only thing we needed to do, get them to understand how to read the abacus. So exactly, they never break this down. Yeah, and so I was like, you know what? I wanted to get to the younger children. So I decided to now, because my boys are older, I have more time, and there's time to be more creative. I was making worksheets for children as young as I was imagining 3 years old. So there's a lot of cutting and pasting and trying to be more interactive. And this is what I got. So I have a book, and then I have a bunch of worksheets that I try to get the kids to understand what the abacus is. But this one specifically was getting them to understand how to read the abacus, because it's a picture, right? There's the concrete, the picture, and then we have the abstract. The abstract is the letter, the number. So that was the thing. Like, it was one of those things that I wanted to do, was I wanted to get the kids in young. And and then this one was specifically for preschool, so they talk about the relationship of the numbers and so forth. We had, like, what's greater than, bigger than, how to count forward, how to count backwards. And then we start going into adding and subtracting. Exactly, they never break this down. It's different in mainstream math, because in mainstream math, it's like teaching fractions with Legos. Yeah, and you know what was really interesting, TNG, is that they actually started using other manipulatives, but they don't use the abacus. So I have, like, these blocks. And I don't know, I never used these blocks. These blocks were never around when I was a kid, but they're starting to use, like, other manipulatives, but they're not using abacus, which is kind of sad. And I think it's because nobody knows how to use the abacus. Nobody understands what it's like. And so that's what I'm trying to do. And in abacus, what we do is we focus. That's what I use. Yeah. A lot of people use, yeah, you're young. I'm old. Anyways, so in abacus, we actually focus in on the add-in. So the add-in is 2. When we do our adding and subtracting, we do 6. And then what we want to do is we want to plus the 2. And what does that look like? Plus 2 means here. Yeah, you're still a baby. That's almost as long as my marriage to the guy. Anyways, I'm not gonna go there. So here we do 4. I'm sorry, we don't memorize in abacus. We don't memorize our doubles. What we do memorize is how do we use the add-in. When we use the add-in is always going to be different. Why? Because I want to know is, do I have enough beads to add 2? When there's enough beads to add 2, this is what we call simple. Simple means that there's enough, there's no need to use a formula. So I want to add the 2, so my answer is 4. And it's the same thing. When we go through the book, here is another one where there's not a lot of question for a plus 4, because you can only do so much. This one is 5, and then I want to add 4. I add 4, here we go. So my answer is 9. Now, what happens when we don't have enough beads? The question would be, let's say 3 plus 2. That's when the formulas come into play. The formulas is what we're teaching children. No, we're actually teaching children how to make a 5. Now, what does that mean? Well, in school, if I can just get it ready, in school, we're teaching children 1 plus 4 is equal to 5. Or the other one is, 4 plus 1 is equal to 5, or 5 plus 4 is equal to 5. The other pair that we teach is 3 plus 2 is equal to 5, or 2 plus 3 is equal to 5. Now, these are the pairs. Do I sell the books? I do sell these books. So if your child is a preschooler, this one would be perfect. You can find my name. Let me find my name. What's my name? My name is Lynette. What's my name? That's my name. There you go. I'm trying to figure out how to do it on TikTok, but I can't figure it out. It's so difficult. Hey, NCMS, can you please do division? I forgot how to do it. I got my abacus now. Okay, let me finish my one thought about plus 5 and then plus 10, and we'll go into division if that's okay. So, Nicole, is that okay? You're all right? So the first thing we're going to do is understand. I'm going to move it up here. We're going to move it up here. So then if you notice the this is what it is. So then what's going to happen is Abacus actually supercharges this information, right? This is a concept. But in regular school, that's all they do. This is it. That's it. I'm done. But no, in Abacus, we make our numbers work for us. Why? Well, what's going to happen is I have 3, but I want to add 4. So if my question is 3 plus 4, notice I don't have enough beads to add the 4. Because I don't have enough beads to add the 4, I can utilize this 5. But to utilize the 5, I need to figure out how to use this concept. So what we're going to do, and this is a little sneak peek, because Abacus is the gateway to complex math, what we're going to do is let's look at this a little bit. And we could say x is equal to 1 equals to 5. I'm sorry. X plus 1 is equal to 5. And if you notice, it's a little bit like algebra. And what we're going to do is we're going to isolate this variable. To make it isolate, right? To isolate the variable, we're going to move it over here. So we have x is equal to 5 minus 1. Does that ring a bell? Anybody? Bueller? So what if we replace this? We know that this is 4. When we do this, 4 is equal to plus the 5 minus 1. When we plus the 5 minus 1, what does that mean? On the abacus, if you look, we want to add the 5 and then take away the 1. So my answer is 7. Which is different than memorizing your doubles. We don't memorize doubles because a doubles only works one way. But interesting enough, you know what's really interesting that I was thinking about it? Doubles only goes one way. You can only add doubles, right? You can't subtract doubles because what is subtracting doubles? It just means everything is 0. However, because we know this to add, we know the inverse, which is subtract. So if I need to subtract 4, all I have to do is subtract 5 and then add the 1. So now we're building on top of our current knowledge. So we're diving deeper into understanding and being more number flexible, number fluent. And so if you notice, it's still the same thing. Now, we did the 4 here. There's the same one as the 5, the inverse, the sister sentence, I guess you would say. You could do 1 is equal to plus the 5 minus 4. But see, they're all related. So again, we're building on the relationships that we already know. And again, we do minus the 1 is equal to minus the 5 plus the 4. Does that make sense? So it's interesting how, like, we know this concept, but now we're supercharging it and we're actually breaking it out. And then what did we just do? We substituted the formula. We substituted this information into here. So now we're going into algebraic operations, if that makes sense. Yeah? Are we okay? Are we tracking? Is that too much? Are you guys okay? Make sense? All right. So that is a little bit about adding and subtracting and about formulas. We have the 10 formulas. Yeah, thank you, Kaylee. We have the 5 formulas here, and then we have the 10 formulas. The 10 formulas means we're going to use a 10. I get it, but how should I explain to my son? Oh, so your son, I would mention, is cats in a tree. So I have it where what we want to do is, and this is what I tell my students, if I had, let's say I had 4, right? My question is 2 plus 4. So what I do is I have 2 on the abacus. Now the question is there enough beads to add 4? No, there's not enough beads to add 4. So what do? Well, the thing is, what we have to remember is we have to go to the cats in the tree. So the cats in the tree always has 5. There's always 5 cats in the tree, and let them wiggle their hands, right? Because wiggling their hands makes them to fidgety and stuff. So it's always good. So have them wiggle their fingers and be like, there's 5 cats in the tree. If there's 5 cats in the tree, I'm going to add the 5. You grab 4 cats, and then 1 cat runs away. So 1 cat runs away, so you take that away. And my answer, it becomes 6. And then you do it again with the next question. So if I have 3, so they see the pattern. You do it again. We have 3, right? Is there enough beets to add the 4? No. So what do? We got to go to the cats in the tree, go to the cats in the tree, grab 4 cats, and 1 cat runs away. So 1 cat runs away, my answer is 7. And then we do it again. Let's do 4 plus 4. So 4, is there enough? So that's the question. The questions are always, the questions are very critical because it gets them to think about their, it gets them to think about their math questions. Questioning if we can do it, and if we can, how do we do it? That's the building of the foundation of critical thinking, critical analysis. And you start asking the questions, they will get to understand how to do it. Does that make sense? So I would keep asking them, is there enough? No, there's not enough. What do? It's a little verbose, but when they get used to it, when they see it, when they understand how to use the abacus, it will be easier for them. But one of the things that we don't teach in math is we don't teach kids how to have a conversation with their we don't have a conversation with their questions. And I think it would be good to have a conversation because then we can critically think what we're trying to do, which means when we start going into multiplication and division, I think it's critical to have a conversation with it because then we know what we're trying to do. So in CMS, you want to have another division question. So we're going to actually dive into some division. And what's going to happen is, oh, hey, Barbara, thank you so much. So in division, we will have a conversation because we need to keep track of things. So the first thing we're going to do is we're going to do division. So we bypassed all of the adding and subtracting. Does anybody have any questions about the adding and subtraction before I go into division? Anybody have any questions about it before I go? I mean, we can always come back to it, but this will be a sneak peek of how we do division. Anybody? Bueller. Where does the cat trick? That came from my head. Because why? Because I needed the kids to understand what it means to add the 5. That's the reason. So in Abacus world, we just say memorize it. But I felt like that the kids needed some sort of story, and because they needed a story, we can relate to it better. So that's why I have the cats in the tree. I don't know if you guys know, but I didn't know because I actually didn't grow up in America. I grew up in Canada. In Canada, we don't have like specific Western terms. Like I didn't know a cat house was not a good term. My husband had to tell me that, and I'm like, oh my God. So I had to change my whole thing. So then it was like, well, where do cats like to go? Cats like to go in trees. So fox wedding, etc. Oh, isn't it a folktale? No. No, it's not a folktale. It was just something that I thought of. Cats in a tree, because I was just thinking, like, when I was a kid, we had a lot of cartoons, and a lot of the cartoons had cats in trees. And it also relates to, well, no. And then what I did here was I had plus 5s, and this one was space themed, and that's where I said like 10 asteroids. And so what does that mean is I need to go to the asteroids? Do I need to go to the asteroid belt? So here, let me do this one. Something that's easier to manage. Okay, so here, the asteroids is the next column over. So when we do 8, we want to add another 8. So it's plus the 10 minus the 2. Plus the 10 just means to go to the next column over and then take away 2. And then my answer is 16. So this was the asteroids belt, and then inside the asteroids there was these cats in a shuttle. But it was just to get the kids to have a little story in their head. That's the only reason why I did that. Yeah. All right. So we have a division. So the first thing we're going to do. Oh yeah, I just made some. Where is my little? Here we go. Okay. Maybe this will help. I made some more labels. Somebody, you're using your hands. Yeah. Oh, I see. Yeah, I was just using my hands like cats in the tree, and then you grab 4 cats. I just felt like it was easier for the kids to see, and then they can do it themselves. Because if you grab 3 cats, you have 2 cats left. If you have 2 cats, you have 3 cats that run away. So I used my hands just to, because that was just the thing. That's all. Yeah, that was the only real reason why I did it. Okay, so what are we gonna do? We're gonna do division. We're doing division. I need a new page. Hello, hello. Ooh, I'm almost done with this book. All right. Let's do 7 divided by 1, like CIA training. 9. Okay. What do we have? We're going to have our quotient up here. We have our dividend is over here. And then we have our divisor. I gotta get these all right, right? The reason why is because I forget the names. I forget the labels. So our divisor is our 7. Our dividend is down here, 119. That's mathlete stuff. Like CIA training. So the first thing we're going to do is we're going to count our question. What does that mean? We need to, with division, we need to take away our dividends and our divisor. There's 3 dividend digits. Take away 1 digit, which is the divisor. Does that make sense? So we have to find our place where we have to find where are we going to put the answer on our abacus. My answer here is 3 take away 1 is 2. To count it, I do 1, 2. So I'm going to have my answer here. The next thing I'm going to do is I'm going to place my dividend on the abacus. So I have 119. It doesn't matter what the number is. We just got to make sure we do it correctly. Does that make sense? So my answer will be here. I need to have my dividend. So we're going to start taking away. My question now goes into who is bigger, my divisor or my dividend. So I'm going to put in my little chart. This is why I have my labels. My dividend is 1. My divisor is 7. So who is bigger? The tree. The 7 is bigger. I'm sorry, the 7 is bigger. So the question is 7 times what is, we got, okay, because the divisor is bigger, we're going to utilize 2 digits. That means we're going to utilize these 2 digits. So it's kind of like long division, but on the abacus. So 7 times what is equal to 11 or less. Does that make sense? So 7 times 1 is equal to 7. So I'm going to add my 1 here. This is my answer. But now I got to take away 7. 7 is a single digit, so I go back here. So right here. So how do I take away the 7? Well, this is where we start talking about our tens formula. To make a 10 plus a 7, if this gets confusing, let me know. We can regroup, and after this question, we can go back to adding and subtracting. So 7 plus 3 is equal to 10. But we need to isolate. We're going to isolate the variable. We're going to isolate our 7. When we isolate the 7, we're going to rewrite it to be 7 is equal to, minus the 7 is equal to minus the 10 plus the 3. Why? Because we need to take away the 7. We're taking away the 7 here. I don't know if that was confusing. So I'm going to take away the 7 is minus the 10, and then I add the 3. So now I'm going to reassess. My dividend is 4. My dividend is 4. My divisor is still 7. So my divisor is still bigger. I need to use 2 digits. So the question is 7 times what is equal to 49 or less? 7 times 7 is 49. So I had my 7 here, and I take away 4, and I take away 9. My answer is 17. NC Miss, did that make sense? So the biggest thing is to really see this. If the dividend is bigger, remember it's skip 1, eat 1. Eat 1. Do another one as fast as you can. Do another one as fast as I can. All right. Okay, so this would be easy. 2, 4, 2, right? So 3, 1, 2, 1, 4, 2. My dividend, my divisor is bigger, so I need 14. So I put 7 and then 2. So it's 71. Oh, I can't see what you're writing. Oh, sorry. Yeah, so if my dividend is bigger, remember the rule is skip 1, eat 1. If my divisor is bigger, I want to use two columns, 2 digits. Yeah. It went I've in my head. It went through my head? Nicole, I'm not sure what that. Like 2 more examples, it might make sense. Yeah. Oh, it went over my. Yeah. We just went over. We went over a lot of things. Thank you so much for the heart me, Barbara. No, we went over a lot of things. So this is like way down the line. The first thing we need to do understand how to read the abacus. Nicole, do you know how to read the abacus? Just to make sure. So to read the abacus, we do 1, 2, 3, 4. And then after 4, I've tried to search on YouTube how to do division, but I couldn't find your method. Ha! Not too many people explain it like I explain it, and I haven't had a chance to put all my stuff online. I've just been okay. Nicole, do you know? Here, I'm gonna count. Is that okay, or do you know how to count? I'm just wondering. I don't know. Sometimes people come in and out, and so I don't know, like, but we did like yeah, we were pushing ahead. We actually should have started with adding and subtracting and understanding how to read the abacus. So we can do a few of these. We can do these a little more, but it would take some time to go through it. Oh yes, I do. I don't mind reviewing. Oh wait, hey, okay. So oh, okay, let's do a little review. So we talk about it 1, 2, 3, 4, and then 5. 5 is the top bead. Anytime it touches the horizontal bar, we have the dot indicator, and this indicator tells me this is my ones place. However, we do 5, 6, 7, 8, 9, and then this is 10. Easy, right? So 10, 20, 30, 40, and then 50. Okay, bam. Okay, so what's going to happen is I can do another division question if you're ready, or we can go back doing adding, subtraction, multiplication. So we could go in and do more division if you guys want to. These questions are relatively easy. It's just learning the method just takes time. That's all it is. So you want to do division, multiplication? Okay, then we'll just keep going. So let's do this one that I did. The first thing we got to do is we have to understand our dividend and our divisor. Does it go from left to right to left? No, it goes from left to right. There's rules. Yeah, it always goes from left to right. We always go from left to right, no matter what. Even in multiplication and in adding and subtracting, we go from left to right. That's just something that, because that's how we talk. So the first thing we're going to do is understand we have our divisor and our dividend. We need to figure out where we're going to put our answer. So, but okay, here's a little caveat. we don't do division until after the students or after the children understand how to do multiplication. So just so you know that there's actually a process, but because we're in live and we just kind of jump around, right? So in class, there's an actual methodology to everything. There's you need to first how to add, subtract, then you multiply, and then you go further into dividing. But you need to know your multiplication fact. Hands down, you need to know your multiplication fact. And using Abacus will strengthen the multiplication fact, because how we talk is all about multiplication fact, if that makes sense. Thank you, Thang, for sharing my life. So we're going back to here. I have my dividend and my divisor. Other reason why I had to label it was because I was getting a little confused, like who was doing what. So what we do is English your first language? Yes, English is my first language. Huh, is my only language. Yeah, my parents were too busy to teach. And where I lived in Canada, there was not a lot of Chinese people, so I didn't learn Chinese. Hey, Noah. All right. Um, but I don't speak Western, right? Like Dukes of Hazzards and stuff. Like I don't know any of the slangs. All right. Okay. So again, what we're gonna do is we need to figure out. She's from Canada, bro. Sometimes but then I moved to California, so nobody really knows, right? Because everybody's like, "Whoa, where are you from?" I'm like, "Yeah, that's a loaded question." But no, I'm in California now. But thank you. Yes, I did live in Canada for a while. I lived in Toronto, Scarborough, Canada. I don't know if anybody knows where that is. That's like close to Toronto. All right. Nicole, so what we're going to do is we're going to figure out our dividend. We have three dividends. One, two, three. What we got to do is we got to subtract our dividends and our divisor to know where our place value is. So when we do it, we have one, two, three digits. Three digits take away one digit. Does that make sense? So it's 3 minus 1 is equal to 2. My place value will be 2. My place value is 2. So I do 1, 2, and I'm here. Now, because my answer will be here, I need to place my dividend. That's the only thing I need to do. Why? Because on the abacus is where I'm going to do my subtraction, and the dividends will help me keep track where I'm going to put my answer. Because if you notice, there's these little small rules like skip one, eat one as part of the thing. So what I'm going to do is I'm going to put my dividend on my abacus. I need to move this so I could see the... Okay, good. So we have 1, 4, 2. This is where we don't pay attention what column it is. This is now just being used to use as a placeholder, if that makes sense. So don't get hung up. This is where we don't. Eastern grammar puts the predicate before the subject in grammar. Western is usually subject then predicate. Okay. Oh, okay. Yeah, it could be the way I'm talking in, but I think of when I talk about it in abacus, I think I'm trying to focus in the what we're trying to do. So I think that's why it gets a little wondering where I'm from. Okay. So we have again, just so you know, we're not going to worry about the place value here. We're not going to say ones, tenths, and hundredths. What we're going to do here is we're just placing the dividend here. That's all this is for. This is only to put as a placeholder. And I think maybe that is why somebody was getting confused. I will have to think about that. All right. The next thing we're going to do is we're going to have to compare. Why? Because we're now going to have a conversation with our question. It might take a little time to get it and to understand. The first thing we're going to do is we're going to notice that we have our 1 and we have our 2. So when I look at it, I have my divisor is 2 and then my dividend is 1. I only want to compare the one digit on my dividend. I'm not comparing the whole thing. So just so you know, Abacus breaks it down into manageable chunks. Because they're manageable chunks, I only need to see this. Now I can compare. I know that my divisor is bigger. When my divisor is bigger, then I know I'm going to be utilizing two digits, two columns, 1 and the 4. So the question is 2 times what is equal to 14 or less? Does that make sense? 2 times 7 is equal to 14. So I have 14, take away 1, take away 4. Take away 1, take away 4. So just like here, I have 7, I take away 1, take away 4, and now I have 0. So what do I have left? I have 2 left. So it goes back to who is bigger, cat or dividend or divisor. But they're the same. And then we just kind of know that it kind of it multiplies itself out because it's 2 and 2, they're the same. But notice, so I'd be skipping this one, and go here. So what times 2 is equal to 2 or less? 2 times 1 is equal to 2. So then my final answer is 71, because what we do in long division, we do 2, so we know that 2 times 2 is equal to 1, 2 times 1 is equal to 2. So then my answer is 71. So, but we don't, in Abacus, we don't do this. We're actually doing long division on the Abacus. We're actually doing our takeaway on the Abacus. So that's why we don't see this part here. I just write it out so then it's more for demonstration. Usually we just have the number. Abacus mode. Yeah, Abacus mode. Abacus mode. That's a really good one. That's a really good one. I think I'm getting it. One more example. Yeah, not a problem. Let's do... I'm doing simple numbers like less than 5 because they're just easier, I think. It's easier to wrap your head around it. So again, we'll do another one, which is 2. That's not a good color. Let's see this. 2 6 3 8. Is that better? Okay. Again, Nicole, are you okay? Are you understanding? So we have to do the same thing. We got to check out our dividers and dividend, right? This is very interesting. I'm on my way to learning math from... Oh, yay! Right? Welcome. Is 6 bigger so we can go eat? So where do we eat? Ah, yeah, exactly. I just see user 2241. But great, if you can, it would be fantastic to learn how to use the abacus and then teach your grandchild. How old is your grandchild? Yes. So, but before we compare, we need to know so if you want to, there is a abacus for preschoolers, and this one's talking about how to use the abacus. I have it where they talk about I have my numbers, my bead recognition, my number recognition, and here's the picture. And then recommended to actually buy an abacus. You can buy it on my website or you can buy it on Amazon. Yeah, that's my name. This is where my book is from. So that's the book. That's my book. So I made like other books. I have like 6 books. I'm on my 7th book, but people are waiting for other books. Yeah, no, thank you. Thank you. I appreciate you. Okay, we're going to do some division. But yeah, before I continue, user 24, we're going to count. I don't know if you know how to count. We're going to count 1, 2, 3, 4, and then 4. Why? Because there's this horizontal bar. Because the horizontal bar, these beads are touching the horizontal bar. Now they're counted. So when we look at it, we have value of 5. The top bead will always be the value of 5, no matter what. We have 5, 5, 5, 5, 5. When they're all touching, these are all counted. But for this example, we only want to do this, 5. Then we have 5, 6, 7, 8, 9. After 9, the tree. After 9, yes, the tree. And then this is 10. Just as we write, we have ones, tens, hundreds, thousands, 10,000. So the idea is understanding that every column is a digit on the abacus. Just as we write, we have the abacus mimics our writing. So if this is 10, this is 20, 30, 40. After 40, we have 50, which is the tree. Thank you, TNG. We have 50, and then 60, 70, 80, and 90. So if we said 91, 92, 93, does that make sense? Do we have tenths on these examples? No, this is the tenths. So the tenths, 20, 0.2, 0.3, 0.4. We're sorting out these cats. We're sorting these cats out. Yes! There's a lot of cats. TNG, you're so funny. User 24, did that make sense? Like how to count it and use the abacus. So the one thing is if you have an abacus, let me know what kind of abacus you have, because I know some people have a 10-beat abacus, and then we would have to modify the abacus, just like in Tokyo Drift. I don't know if anybody's seen Tokyo Drift, but I have 3 boys and they've watched all of car stuff. So there's this one called Tokyo Drift when Mater gone through modification, and that's what I remember. If there's a 10 beat, then we do multiplication. I mean, for the divisions, are we using tenths? Or no, it won't be. Fast Furious movie. Yeah. So no, this is not a tenths. There's no decimal in this one. Tokyo Drift was a great movie. All right. So we're back to here. So user 24, I'm not sure if you're still around. Let me know if you need more assistance for counting on the abacus. We're going to continue on with division. I was going to say multiplication, but All right. So the first thing we're going to do is we're going to understand where our place value will be. So 3 take away 1 is equal to 2. So I got to go 2. 1, 2. Because my answer will be here, I'm going to put my dividend here. 6, 3, 8. After that, what do? We have to compare. Now, just as Thang mentioned, right? We have our dividend, our divisor is 2, our dividend is 6. So because my dividend is bigger, this is where I skip 1, eat 1. Skip 1, eat 1. So I'm going to skip this column. That's what that means. I'm going to skip this answer column to be over here. I'm only going to utilize this one column here. I'm only going to take this one right here. So my question is 2 times what is equal to 6 or less? 2 times 3. So I'm going to add 3 on the abacus. I add 3. Then I go back and I take away 6, because that's what I need to do. I need to minus the 6. And now what do? Well, I have to compare because I have digits still. I still have dividends. There's 3 here and there's 2 here. So 3 is my dividend, 2 is my divisor. Again, it's still 3 is bigger. Dividend is still bigger. So I still need to skip 1, eat 1. What's going to happen is 2 times what is equal to 3 or less. 2 times 1 is equal to 2. So what's going to happen is I put my 1 on the abacus. I put 1 on the abacus. Remember, I skip 1. This is the column I skip. So I add my 1 here. And then what do? I take away 2. So I go back here onto my dividend and I take away 2. Now what do? Well, I still have dividends. My question is 1 or 2? Who is bigger? Dividend is 1. Divisor is 2. Divisor is bigger now. So what does that mean? I have to use 2 columns. These are the 2 columns I'm going to use. So the question is 2 times what is equal to 18? 18 or less. 2 times 9 is equal to 18. Take away 1, take away 8. We can do it again, right? We divide, we compare who is bigger. Our dividend is bigger, so we're gonna stay here, and it's gonna be 3. 3 take away is 6, so this is 0. So then we do it again. 3 and 2. 3 and 2 is only 1. So 3 comes down, take away 2 is equal to 1. Then what happens? We bring it down and we have 8. 2 and 8 is 9. So that's my answer. 3, 1, 9. But I don't need to do long division because I do it on the abacus already. Abacus mode. Absolutely right. Abacus mode. Does that make sense? So these are specific. But that's the thing. Like all of these questions are very specific. I'm not just going to give you any question. They're very, very specific questions. Heavy. This is how computers were created. Yeah, they were talking about how the abacus was like the first parts of doing computers and stuff. And okay, I'm not smart enough to know that, but that's what I've heard. Thank you for liking my live. Okay. Does that make sense? We can do another one if that's okay. Nicole, how are you doing? Is it okay? Are you all right? I want to make sure you're okay. I mean, there's 11 people here, but I only see TNG and Thang commenting. Hey, Melinda! Welcome! It's division, but also multiplication. Okay. If the divisor is bigger, do we go back one column? No. If the divisor, hey, Robert! If the divisor is bigger, then it's using 2 columns. If the divisor is smaller, it's skip 1, eat 1. So that means I skip 1, I take away 1 column. Skip 1 column, which means the columns, right? Skip 1 digit, skip 1 column, and then subtract 1 column. Yeah. So the divisor, if the divisor is bigger, then you use 2 digits. So like here, the divisor is bigger. I'm going to use 2 digits. I'm going to use the 1 and the 4 to figure out what my answer is. So that's why I have 2 times what is equal to 14. That's why. Yep. Okay. Questions? Want more division? We're okay? What are we doing? We want division or we want multiplication? We could do either or. We can even go back to addition. Addition and subtraction. That is a very underrated. Multiplication can get really complicated really quick. I love both. Either is fine. You guys are not helpful. We can continue on. All right. A lot of people. Okay, you know what we can do? Let's start doing some multiplication because maybe people don't know it. And so we can do that. I don't know if Nicole, I'm here for division. Oh, you're here for division. Okay, we'll do division. All right. We'll do this one. So we'll do 3.375. Now the difference here is now we have to start comparing more than just 2 numbers. Again, we have to find our place value. Our place value is 3 digits and then 1 digit. So we have 3 take away 1 is equal to 2. So again, we're at the 2 digit. 1, 2. And I'm going to put my dividends on the abacus. 3, 7, 5. When I have it, I have divisor and my dividend. Just to keep track, my divisor and my dividend. Can you do 2-digit divisor and 3-digit dividend? Yes. I would have to find that but I don't mind what chat is up for. Well, too late. Too late, Robert. All right. Kevin Smith. We can. The only thing is I have to find questions, and I don't have questions right now. I mean, I would have to look for my questions, but I can do it later in a little bit, because I kind of like it if they can zero out. It's just nicer that way. It's just easier. But I will keep in mind two-digit divisor and a three-digit dividend. Oh, we've done that. Okay. I know I have some questions. Okay. So the first thing we're going to do, is we're going to compare. So we have our dividend and our divisor. Notice we have 3 and 3. They're the same. So what do we do? Well, now what we need to do is go to the next column, 7, and right here we're going to pretend there's a 0. So there's a 0 and a 7. Our dividend is bigger. Our dividend is bigger. So what is it? It's skip 1, eat 1. So I'm going to skip this one, and I'm going to only talk about this. So the question is still 3 times what is equal to 3 or less? 3 times 1. So I add 1 to my answer, and I take away 3. Then I do a comparison again. Now it's 3 and 7. 7 is still bigger. I still just need to skip one column. So the answer is always on the line. That's how I do it. That's how I do it. I mean, you could do what times 3 is equal to 3. You could do it that way too. It's up to you. It just depends on how flexible you are. It doesn't matter because it's multiplication. Multiplication, it doesn't matter if it's flipped or not. So you could do it that way. I do the line just to show the children. It's always about the children. To show the children what I'm trying to talk about. Because I don't do x times 3 is equal to 3. I don't do that. Because I think that's confusing because they don't know what x means. But they know what a missing factor is, because that's a very common concept for kids. So again, what times 3 is equal to 7 or less? What times 3 is equal to 7 or less? 3 times 2. 2. So I add 2. Thank you, Melinda. I add 2 to my answer. I go back and I take away 6. I'm left with 2 more. I'm left with 15. I only need to compare this digit. I don't need to compare 15. I only compare the one digit. So the question is who is bigger, 3 or 1? 3 is bigger, so I'm going to use 2 digits. I'm going to use 2 columns. So the question is 3 times what is equal to 15 or less? 3 times 5. Thank you, Melinda. 3 times 5 is equal to 15. Take away 1, take away 5. So my answer is 125. Okay, so Kevin Smith mentioned to have a 2-digit. Let me see if I can find it. Is it here? Oh, I think it's over here. Now, it's a little bit different than doing the 2-digit one. Is a little bit different than mainstream math, because what we do is we break it up. We don't. If I can find it. Where's my? Oh boy. Hold please. Hold please. Yes, thank you. 125. I'm just looking for, let's see, I'm looking for questions. Just because it's just easier. Let's see. Yeah, I'm just looking for questions right now. I think this one? Okay, there we go. Okay, there we go. We got it. We got it. I got it. I got it. I got it. Okay, let's see how this goes. Okay, are we ready? 542 divided by, no, 588 divided by 42. We could do it this way. We could do it this way. It doesn't matter how we write it. It doesn't matter how we write it. As long as we write it. Doesn't matter, right? We're okay with that? So again, 3 and 2. Okay, I need to use my other abacus because I don't have enough beads. I don't have enough columns to work it. So that's why I have this one. What's going to happen is we have 3 digits here, 2 digits here. 3 take away 2 is 1. Does that make sense? 3 take away 2 is 1. So my answer is going to go here, right in the middle. But what I'm going to do is I'm going to put my dividend. It's 5, 8, 8. Now, excuse me, the difference here is we still break it up. We do partial, what do you call it? Partial dividend? Partial quotient? Partial something. We do it like in manageable chunks. So the first thing we do again is still compare. Who is bigger, our dividend or our divisor? Our dividend is 5, our divisor is 4. So again, our dividend is bigger. So we still need to, thank you, Melinda, we still need to skip 1, eat 1. This is still the same concept. There's nothing changed here. So the first thing we're going to do, so we're going to skip this column. I'm going to put my finger over here. What's going to happen is we do 4 times what is equal to 5 or less. 4 times 1 is equal to 5. No, 4. Sorry, my bad. Yes. So I'm going to put the 1 here, and I take away the 4. If you remember how to take away 4, to take away the 4 is minus the 5 plus the 1. So I minus the 5 and I plus the 1. Now, what I did here for the first dividend, I have to do it again for the second dividend. So we had 4 times 1 is equal to 4. Now I have to do 2 times 1 is equal to 4. I'm sorry, 2. 2 times 1 is equal to 2. 2 is a single digit, so I go back 1 column and I take away 2. We all right? Does that make sense? Let me go back. It froze, so I didn't see anything. Okay, so let me try it again. So we have 4 times 1 is equal to 4. This 1, if we do 4 times 1, we got to do 2 times 1 is equal to 2. Because whatever we do to the first dividend, we got to do it again to the second dividend. We don't need to do anything here. We just need to do a takeaway. So that means 2 times 1 is equal to 2. 2 is a single digit, so I go back 1 column and I take away 2. I take it away from here. Hi, Evie, go crazy. Okay, we're okay? So now we'll go back. Who is bigger? Our divisor is 4. Our dividend, this one right here, is 1. Our divisor is bigger. If our divisor is bigger, we're going to take these 2 digits, these 2 columns. The question is 4 times what is equal to 16 or less? 16 or less. 4 times 4. Exactly, Melinda. Thank you. 4 times 4 is equal to 16. So I add my 4 here. I take away 16. Take away 1. Take away 6. Whatever I do to the first digit, I got to do it again to the second digit. So the second digit is 2 times 4 is equal to 8. 8 is a single digit. I go back one column and I take away the 8. That's it. So my final answer is 14. Yeah. Does that make sense? Again, it's about conversations. We have conversations with our abacus. We have conversations with our questions. Yeah. This was a nice one because there wasn't too many rules. But division has a lot of rules, and we've actually jumped a lot to get to here. I think Nicole left. Is Barbara still here? Oh, hey, Barbara. I was just talking about you. It's complicated, but I think you get it. Rules are fun. Yeah, rules makes the guide, makes a nice, like you know where to push and pull. Yeah, it's a little complicated. It's a little complicated only because we didn't progress to this. We kind of jumped. Right? So I notice in like regular mainstream math, we jump through a lot and then we try to bring in strategies like, oh, if it's 800, 588, let's round it to 600. And then after that, we have to like take away 40 and then the numbers are easier and la la la. And it's like, you could, but then those are estimations. In Abacus, we can take a look at the numbers and see if that makes sense. But yeah, but it goes back to, if you can understand the rules in the beginning, knowing this part here would just be building on top of each other. Yeah, thank you, Kevin Smith, for liking. Abacus, you do it all without writing? Hey, Kay! It's so late. You're awake? It's only 11:30. It's 12 a.m. there. Yeah, see? No, I'm on California. I'm mathing. Midnight math, Kay. Abacus, yes, you do it without writing. Sometimes the kids need to like track the numbers because the numbers get really big, but usually it's all on the abacus. Usually everything's on the abacus. The writing is to demonstrate. It's to demonstrate the layman people. No, I'm kidding. I do the writing so then we can make sense of what's going on. But other than that, I mean, it would just be a bunch of like me doing this and then people would get lost. So that's why I do a lot of the writing. Yeah. And then trying to figure out how to organize it and try to make sure that everybody is tracking like a horizontal bar. Yeah, I love this. All right. So, hey, Sammy just joined. Sammy, we're going to talk about how to count on the abacus. I'm going to use this one instead. So, to count on the abacus, we do 1, 2, 3, 4, and then 5. Anytime the beads are touching this horizontal bar, we're going to count it. So this always has a value of 5. So we have 5, 6, 7, 8, 9. As we go through, this is 9. Every time each column has 9. So this is actually 99. And then we do this one, 999. And then this one, 9,999. Oh my God, dang, that's really late. You guys are such like night owls. So I don't know if Sammy's still here, but did that make sense? As we go through, it's always good to understand how to read the abacus because then you can actually start utilizing it and doing some calculations. But you know, really, if you really think about it, you do the calculations in your head. You do the calculations, and that's why I think makes it different, makes it interesting but you see it. No, I just have insomnia, but my sleep meds should work soon. Or I could talk monotone and try to put you to sleep. Enter as you asked. I don't know if I can be monotone thing. My kids think I'm a little corny. All right. Okay. So enter as you asked. Yeah, I don't know. I don't see anything else. Oh, ASMR Abacus. Yay, Apple. Another division card. Okay, yeah. Nah, this is too interesting no matter the tone. All right, all right. Okay. So, Rob wants another one. Rob wants another one. Okay, we're going to do another double digit or single digit. What do you want? Double digit or single digit divisor? Um, what do you want to do? Either? Okay. Double, double, AMLB, both. All right, we'll do double. We'll have this one. We'll do this one. Let's see if I have enough room. That's always the thing. Do I have enough room? I love it. This is a great challenge. All right. So the question is, let's do it this way. 741 divided by 57. I saw Sammy enter right after you mentioned them. Yeah, I saw Sammy too, but it's okay. It's okay. There's that one person that like said, I'm a bad teacher, and I'm like, I'm not for everybody. Anyways, okay. Does that haunt me? No, it doesn't haunt me. I don't think people on the internet can rattle me. There was this one spammer. And oh yeah, I remember that one spammer like kind of 2 and 3. Yes, exactly. So dividend and divisor. So that's the other thing, right? Keeping it track. Dividend is over here now. Divisor is over here. So we have 3, take away 2, and I still got to use this one. Equals to 1. So we have 1. We're going to put our divisor over here. Or sorry, dividend. We're going to put our dividend here. 7, 4, 1. Then 7 is bigger, so you skip 1. Well, yeah. So if I did my little chart, I have my divisor is 5 and my 7. Yes, so 7 is bigger. Yes. So I skip 1, eat 1. What's going to happen is 5 times what is equal to 7 or less? 5 times 1. Yeah. Oh, you know what? Okay. There we go. There we go. All right. 7 times 1. 5 times 1 is equal to 5. So I put my 1 here. Take away 5. So I take away 5 here. So I look at this one here. I don't look at this anymore. I go here. 5 is my divisor, and my dividend is 2. My divisor is bigger. So I take 2 digits. I take these 2 digits. No, thank you, Melinda, for letting me know. Yeah, because the camera's so small. Anyway, so 2, right? Why? Because the divisor is bigger. So what does it do? I do 5 times what? Oh, no. Nope, that's wrong. I forgot this one here. So 7, what I do to the first one, I got to do to the second one. I got to do that. Take away 7. Yep. You're right. Sorry. My bad. So 7 is a single digit. I go back one column, I take away 7. Take away 7. Minus 7 is equal to minus the 10 plus the 3. So I minus the 10 plus the 3. Minus the 10, add the 3. Plus the 5 minus the 2. I'm just thinking. All right, what's next? So now, So now, my 5 or 1, 5 is bigger. So I take 2 digits. These are the 2 digits. 5 times what is equal to 17 or less. 5 times 3 is equal to 15. So I add 3 here, take away 1, take away 5. Whatever I do to the 5, I gotta do the 7. 7 times 3 is equal to 21. Run that back. Okay, I will. So we take away 20 to take away 1. All right, let's do it again. I'm going to use a different piece of paper. Let's do that again. Yeah, let's do that again because I keep messing up. Okay, I think maybe this will be my last one because I'm getting kind of tired. All right, 741 divided by 57. All right, so again, we do 3, we do 1, we do that. We do 1, and we do 7, 4, 1. Who's bigger, 5 or 7? 7's bigger, so I skip 1. So the question is 5 times what is equal to 7 or less? 5 times 1 is equal to 5. So I add my 1 and I take away 5. Whatever I do with my first one, I gotta do to the second one. 7 times 1 is equal to 7. 7 is a single digit. I go back 1 column and I take away 7. I want to take away 7. Minus the 7 is minus the 10 plus the 3. Minus the 10, add the 3. Problem, we cannot add the 3. What do? Plus 3 is equal to plus 5 minus 2. These are formulas that we need to remember from addition and subtraction. This is why it might be a little complicated. This is why it might be a little different, only because we've bypassed all of this information. So this is why I write it out, and having this minus the 7 is equal to minus the 10 plus the 3 is the concept of borrowing a 10. It's also how to make a 10. So this is the concept of making a 10. But once you understand how to make a 10 and make a 5, then it doesn't matter what the combination is, because you're going to be able to utilize it all, just like we did here. What we did is we isolated this variable and we substituted this equation into here. So what we did is we minus the 10 and then plus the 3. There's not enough to add the 3, so we need to plus the 5 and then take away the 2. That's a little bit. Does that make sense? So what's going to happen now? Now we go back to our question, because we're done with our calculations here. Now we go back to our question. When we go back to our question, it's 5 is my divisor, 1 is my dividend. 1 is my dividend. Because my divisor is bigger, I'm going to utilize these 2 columns. These are the 2 columns I'm going to use. So that means my question is 5 times what is equal to 17. 17 or less. 5 times 3 is equal to 15. I add 3 on my abacus. I take away 15. Take away 1. Take away 5. Whatever I do to the 5, I got to do to the 7. So afterwards, it's 7 times 3 is equal to 21. 21, take away 20, take away 1. My answer is 13. Thank you for the hearts. Does that make sense? Hey, Iris. Did that make sense? Okay, that makes sense. A bit too advanced for me right now. Exactly. It's only right now because this is what we learn for adding and subtracting. And that's why I have these little like flipping formula. As long as you know how to plus the 5 and plus the 10, these are the fundamentals of adding and subtracting. Hi, Iris. I'm so intrigued. Okay, hold on just a minute. And so these are the flipping formulas, meaning that these are the only formulas you need to know to add anything. Add anything and everything, if that makes sense. Okay, Iris, what we're going to do is we're going to learn how to add, we're going to learn how to read the abacus. So the first thing we're going to do is we're going to understand. Can you make a video about division so when I forget how to do it, I can watch your video? Yes, of course, I will. Yes, I will. Okay. So Iris, the question is how to read the abacus. So the abacus is 1, 2, 3, 4, and then notice when the beads are touching the horizontal bar, they're being counted. We notice that this is only 4, so how do we do 5? 5 is always going to be the top bead because, yeah, not a problem in CMS. The way the 5 is, the top bead will always be 5. So because it's touching the horizontal bar, we count this 5, no matter what. So this is 5, these are all 5. So when we do this, then that means all of these 5s are counted. But in this scenario, I just want to do 5. If we did this, this would be 55. If we did this, it would be 555. So let's go back. So this is 5, we have 6. Notice we have 5 plus 1 is 6. Then we have 7. 5 plus 2 is 7. And then we have 8. 5 plus 3 is 8. And then we have 9. 5 plus 4 is 9. And then you might be asking, well, what's 10? 10 is exactly what you think it is. It will be this because we have our ones, our tens, our hundreds, our thousands, and our 10,000. Just as we write on our numbers. So we have place values because the place values 9 plus 10. Huron's formula. If we did that, yes, you're right. Yes, you're right, Iris. So we do 9, and then if we want to add the 9 again, we want to plus the 10, take away the 1, and that would be 18. Exactly. Yeah. So you know how to use the abacus, or you just know or is it because you know how to make a 10? Because there's also making a 5. The other thing is making a 5. So we have 4 plus 4. Plus the 4 is plus the 5 minus the 1. Huron's formula? It is? I don't know. I don't know what formula that is. I'm not sure. But there's 2 sets of formulas that we need to understand. I was trying to do 9 plus 1, so I just know how to make a 10. Oh, I see. Yeah. Well, there's more, right? To make a 10, there's a whole set. To make a 10, we have a 10 minus 1. Why are we doing this? Now, the question is if we remember algebra, we had x is plus 1 is equal to 10. It's the same thing if x plus 2 is equal to 10. When we do that, what we just did is we isolated the variable. We talked about 8. So the question is we want to isolate this variable. We got to move it over here. So x is equal to 10 minus 2. So what is x? X is 8. So our formula we talk about is plus the 10 minus the 2. When do we do this? It's only when we don't have enough beads. So the question is 9 plus 8. So if we do 9 plus 8, we do 9 and we add the 8. There's not enough beads to add the 8. So what do? We have to plus the 10. Plussing the 10 only means go to the next column. That's all it means. So we go to the next column, we add the 10, and then we take away the 2. We have to remember to take away the 2. Because if we look at it, 8 is not equal to 10. What we have to do is we need to balance this equation. To balance this equation, we have to minus the 2. Does that make sense, Iris? Yeah. So this is about adding a 10. It's the same concept when we add the 5. So the question is 3 plus 4. Why? We don't learn our doubles. What we learn is our add-ins. So we have 4. Notice there's no more beads to add the 4. The next phase, the next formula that we need to know how to use is how to make a 5. We know that 4 plus 1 is equal to 5. And again, that's a little more tricky. 7 plus 7. Let me go into that. So let me finish this one because that's a two-step equation. So here we have, we're going to isolate the formula. We don't memorize our doubles, right? What we do memorize is the add-in. So we have 4. We're going to isolate the variable. So the question is 4 is equal to plus the 5 minus the 1. Does that make sense? So what we're going to do is we're going to substitute this into here. Again, we have to plus the 5 and we take away the 1. Does that make sense? Because it's going to rely on our next thing, which is doing a two-step equation. So what we just did is the beginning parts of algebra, if that makes sense. Are we okay with this? Do you understand this part here? This is how we make a 5. When we make a 5, we have these pairs. These pairs help us utilize this 5. We want to make sure we work. Okay, great. So then the next question you had was 7 plus 7. Now, this is a little tricky. Why? Because we have our 7, and to do the 7, we know how to subtract it. So add the 7 is plus the 10 minus the 3. So let's plus the 10. But now when we want to take away the 3, we can't. Well, we know to do the 5. We know we can minus the 5. Minus the 3 is equal to minus the 5 plus the 2. Whoa, plus the 2. So that's how we work it. Why is this a two-step equation? Because what we just did is we took our one equation and then we added this equation. This is why it's a two-step equation. And once you understand the concept of two-step equation, then everything else is golden. So we have to minus the 5 and then take away and then add the 2. So my answer is 14. There are very specific questions that are two-step equations. So in addition, what we just did is I just did a run through of our simple stuff, our adding of a 5. These are all the adding of the 5s. This is all adding the 10s. This is where the yellow is. And then what you were asking here was two-step equation. All of these questions that you see here are two-step equations. Okay, I see that, but definitely a second step. It's hard to see. Yeah, the two-step equation, it goes with practice, right? And so not all questions are two-step, but like that's the difference between the two. I had a parent that would be like, well, I want my kid to know 5 plus 8, and isn't 8 plus 5 the same? No, it's not the same because one is a two-step and one is just a regular one. So if we look at it, 8. Let's do 8. We do 8. We want to plus the 5. That's what we want to do. We want to plus the 5. So adding the 5 is equal to plus the 10 minus the 5. Easy, right? Plus the 10 minus the 5. Not a problem. But the answer is 13. Well, isn't it the same over here? No, it is not. Why? Because this is where we do the two-step. How do we know? Because there's not enough. We add the 5, and then we add the 8. Is there enough to add the 8? No. How do we add the 8? Plus the 8 is equal to plus the 10 minus the 2. So we plus the 10, but we take away the 2. Now we can't take away the 2. There's not enough beads to take away the 2. How can we take away the 2? To take away the 2 is minus the 2 is equal to minus the 5 plus the 3. So I minus the 5, and I add the 3. My answer is 13. So these are not the same. It's all depending on the add-in that's being added. Does that make sense? So as long as you know how to add it, so that's why when we look at it, there's steps. So here, notice we have two formulas for plus 1. Plus the 5 and minus plus the 5 or minus the, or plus the 10. The question always starts with, can you add 1 bead? Yes, you can, then just go forward. The next one is, can you add the 5? And then after that, can you add the 10? So it goes in order. You just need to know the order and what to add. That's it. But you focus on the one thing. Don't look at everything. And then when you're done, then you take a step back and you'll be like, oh, I understand now. Yeah. I hope that makes sense, Iris. Whew. That was a really quick rundown. I don't know if anybody else paid attention. Oh, okay. Did that make sense? Did you understand? So that was yeah. It's and and then if there's the addition, then there's the subtraction, and it's the same concept, but this time we're doing takeaways. Yeah. Okay, great. Okay, great. Yeah. Any other questions? Okay. I think. Okay, Robert. Okay, good. That made sense. I'm happy. I'm happy that made sense. I have no more paper. I have paper. This is funny. This is great. This is fantastic. I just gotta find more paper. All right, more paper. So, I try to stay quiet sometimes. Melinda, you're so funny. I do enjoy the conversations. You guys are funny. Can I see the subtraction using 5? Okay. Okay. So, yes, let's talk about it. And I had to mark some blank pages because my kids are just all over the place. So, I have some blank pages and some random ones. Okay. Easy. All right. The first thing we're going to do, MLB, is 11 take away 7. That would be easy. Why? Because we know 11 is this. And now what we're going to do is we're going to take away 7. Minus the 7 is equal to, do we know how to minus the 7? This is what we consider borrowing. In school, this is what we call borrowing. Does that make sense? So if we need to minus the 7, we need to minus the 10 plus the 3. Oh, sorry. Minus the 10 plus the 3. So if I need to minus the 7, yes, exactly. Minus the 10 plus the 3. What does that mean? I only need to take away the 1 here, 10. That's all that means. Take away 10, and then I add the 3. I'm going to add the 3. So my answer is 4. Did that make sense? Is that all right? I can do another one. We could do you want to keep with 7 or do you want to go with a different number? We can do a different number. And it's the same concept. The biggest thing is knowing your add-in, right? The biggest thing is knowing how to do the add-in. So the next question, let's do 13. 13 take away 9. 13 take away 9. Thank you, Melinda. So we do 13. That's 13. And we take away 9. How do we take away 9? See, we know how to add the 9, so we're just building how do we take away the 9. So minus the 9 is equal to minus the 10 plus the 1. So I take away the 10 and I add the 1. Yes, thank you, Melinda. Right? So my answer is 4. So girl makes. Oh, hey. Okay. Okay. We do another one. Let's do. Here's a good one. Well, let's do. Okay, we did 7, right? We did 7. We did 9. We could do 12. 12 take away 3. This is a good one. Why? Because now we have to start thinking about what can we do. We have 12. And then the question is, we want to minus the 3. Can we take away the 3? No, we don't have enough beads. Can we take away the 5? No, there's not enough beads. So we got to do is we got to take away the 10. Minus the 3 is equal to minus the 10 plus the 7. So we minus the 10 and then we add the 7. My answer is 9. But again, these are steps. We got to see if we could take away the 5 first. If we cannot, then you go to the 10. Because if you go straight to the 10, then you're doing too much. You're doing too much too quickly. Too fast, too something. So that is minus the minus 10s. We can do minus 5s. Same thing. It would be 15 minus 3. Well, isn't that the same? Well, let's check it out. Let's check it out. So we have 15. We have 15. Can we take away 3? No, we cannot take away 3. There's no 3 to take away. Well, can we take away the 5? Yes, we can take away the 5. So what do? Minus the 5 plus the 2. So I take away the 5 and I add the 2. And my answer is 12. Does that make sense? Are you asking for double digit? So we could do double digit. Let's do a double digit. I'm sorry, not double digit. Let's do a two-step equation. So let's do 14 minus 6. Do you know those do you know those tasks flow charts? What is what I see going through these? Do you know those tasks flow charts? Yes. That is what I see when I go. Yes. I something like this. No, where did I put it? So what I did, it's going to be I made this as part of my, I'm trying to find my sheet. And it's, because yeah. So it's something like this. It's a framework, right? The framework is, can you do it? Yes. Then you add the beads. No. Then you minus the 5. Can you minus the 5? No. Yes. Is that what you're talking about? And then this is, yeah. And then there's a subtraction. This is subtraction. And then there is, yeah. This is what I go through too. But it goes through each and every digit. So it's the same thing with the tens and the same thing. So any of these numbers can be anything. And that's why, I don't know if you were here for that, but I realized that working with these formulas, it's like working with knitting. It's like knitting, because you can make a scarf out of it, or you can make a sweater out of it, and it just depends on how you're using the formulas. But yeah, it's exactly what you're talking about. So the next thing we're going to do is 14 take away 6. So what's going to happen is we're going to have 14 take away 6. When we take away 6, the question is there enough? No, there's not enough. What do? Minus the 6 is minus the 10. Minus 6 is equal to minus 10 plus 4. So we minus the 10, now we have to add the 4. Right, but the problem is there's not enough beads to add the 4. What can we do? Plus 4 is equal to plus the 5 minus 1. So I plus the 5 and I take away the 1. So my answer is 8. Yes, thank you. Yeah, exactly. Exactly. Educated and opinionated. Thank you for the follow. That's funny. Opinionated MSN. Okay. Do kids find this helpful? Are they able to master the base 10? And currently we use base 10. Yes. The kids find it very helpful. Do they like it? They don't like it because they don't like more work. But once they understand it, then it's really easy for them, because this is very simplified, right? Oh yeah, I see. We currently use base 10. Yeah, I have those blocks. Yeah, you're talking about like something like these. But the problem with these, I find, is that they don't provide place values, and so I think it's harder for them, because we also don't do grouping and regrouping. But in Abacus, we don't call it grouping and regrouping. We only call it add plus the 10 minus the 10, because that's all we're doing. That's really all we're doing, is we're adding a 10 and we're taking away the 10. So the formula is a very common, very fundamental concept for us. when we minus the 10 and then when we minus the 10 and add the 10. That's carrying over and regrouping. But it does get complicated depending on your numbers. So there was this one where they were like, well, one person was like, oh, well, how do you do these numbers? And it's like, we can do it, that's not a problem, but does the kids really understand how to manipulate and move through these, right? Because there's a lot of information here. If I want to add, if I want to add here, if I want to add 6, am I able to know how to minus the 4? And that's just one of the things that they need to memorize. This is something that they need to really understand and needs to go under, but Abacus really makes it solid, if that makes sense. My kids have gone, I have 3 boys and they all gone through Abacus, and having understand Abacus, they don't need to worry about Common Core because Common Core is really actually Abacus. Hey, Gabrielle. Yeah. And so I know they're starting to talk about new math, and new math is kind of like Abacus, but the issue is I notice is that they have to write it out. Whereas in Abacus we don't write it out. What we do is we see the numbers. We understand how to use, we understand it through the numbers, and we see the limitations of the numbers, which I think is very helpful, right? So it's very helpful to see that if I want to add 4, I can't. So what do I do with it? I could see that there's a limit. So I need to figure out where my abacus goes. I need to figure out where the formula goes. So I think it's really helpful to see it on the abacus because there's restrictions, and to figure out how to work around the restrictions. And I think that's what the kids are the differences. Whereas we have these, right? We have these, but there's really no restrictions. There's like, you can do 100 of them. It doesn't matter, right? But there's no restrictions here. The only restriction is that you can't break a 10. So that means you have to get all these little blocks, if that makes sense. It does look very neat. Yes, and it's very neat and very tidy. But I don't teach with blocks, so I don't know I don't know the strategies behind the blocks. I just know that they have them. Like I know to group them together and to use them, like we have to break it apart. It's fine to show quantity, but the human eye can only understand so much. So that's why I think it's easier to show on the abacus that if I just need to take away the 10, I just do this. If I need to add the 10, I just do that. And I feel like it's just simplified because abacus makes it manageable chunks. What do I mean? Well, when we do multiplication, one of the things that I was talking about was multiplication. So is 23 times that by 48. So in new math, in new math, when we do this in abacus, we do this too. But in new math, they have to write it out. They have to do 20 times 40 just to keep the place value. Whereas in abacus, we don't need to. Same thing. We just need to count the digits, and the abacus will help us place it. So we do 1, 2, 3, 4. Anytime we have 4 digits, we're counting all of our digits. I'm going to be around here somewhere. So my question is 4 times 2. See how 4 times 2 is manageable as opposed to 40 times 20? We don't need to do this in abacus. So this is 4 times 2 is 8. So we add 8. Is there an abacus with no 5 bead but 9 beads per column instead? No, it's not 9 bead. It'd be 10 beads. And that would be probably a thing from Target that has 11 beads, which was really strange. There are the 10 bead ones, and the 10 bead ones, if you have a 10 bead one, we can modify it. But I don't know if there's a 9 bead one because it wouldn't make sense to me. Okay, so we're here. So we added the 8. So the next thing we do is we go from 2 to 3. In new math, we do 3 times 40. But in abacus, we do 4 times 3 is equal to 12. See how this is interesting? No, but if you could break it to 9, to have 9. Yeah, you could break it, but I don't see how. I guess you could. Sorry, 12. So, no, that's wrong. 1, 2, 3. 8 is a single digit. 8's a single digit. I have to go back one column. I add 12. 1 and then 2. And now I have to reassess. I've already done with my 4 and I have to reassess. 8 times 2. 8 times 2, right? 8 times 2 is 16. 1, 2, 3. We're 16. In new math, we got to do 20 times 8. But in Abacus, we just do 8, 1, 6, plus 1, plus the 10, minus the 9, plus the 6. And then 8 plus 3. 8 times 3, or 3 times 8 is equal to 24. Add the 2, add the 4. Add the 2, plus the 10, minus the 8, add the 4. So my answer is 104. Yeah. Hey, Shantonia. Does that make sense, Iris? Yeah. Okay. Okay. Have a good night, Thang. I'll see you next time. Yes, I will see you next time. See you on my next live. But I think that I'm going to head to bed too. I mean, I've been on for a little bit. But Iris, did that make sense? So, yeah. So there's the new math, but in Abacus, we don't need to do that. Yeah. You have a good night. Yeah, yeah, yeah. That went a little fast, but I think so. Oh, sorry. Okay. Well, we can talk about that in the next time. Sorry. I apologize for. I'm just kind of breezing through because you're getting it so quickly. I'm thinking I can go that fast. Yeah. It's always good to see you too, Melinda. Thank you so much. I appreciate you guys like having a conversation. We were mathing, midnight mathing, but it is 12 for me, and so I'm gonna head to bed. But Iris, I hope to see you in my next live, and we can talk more about it. You know, always start from the very beginning, and then we go into adding, subtracting, multiplication, division. It all depends on the group of people too. So, but thank you guys. Thank you again for joining. Thank you again for the conversation. And Iris, I hope to see you soon. Melinda, I will see you soon. And Thang, I will see you soon as well. And Robert too. Robert, you're always so quiet. Robert's so quiet. Please don't apologize. I'm so intrigued. Good night. Yes, catch you up on your post vids too. Oh yes, thank you. And then what I got to do is I got to do division. So in CMS, I'm not sure if she's still here. We have to do division, do a post of division. All right, I'll have to do that. It'll be a little bit, but yeah, I gotta put that in my notes. Division. You know, I can just use these ones. I'll just do these ones. Okay. So, okay. Thank you. You too, and I'll see you guys in my next live, probably tomorrow morning. But I gotta do like pages and books of my. That's what it is. I have to make sure I'm working on my book. All right. Thank you guys. Have a good night. Have a good night. Bye. Sleep well.